In this problem, what I want to do is I want to determine the magnitude of this force, F, so that the resultant couple moment is 400 Newton meters in this clockwise direction. So this is what I want my resultant moment to be. Now, if I observe this, I see that I have three different couples. I have the 600 Newton force couple, I have a 250 Newton force couple, and I have this minus F force couple. What I need to do with these couples is, if possible, I want to determine the perpendicular distance. I know the perpendicular distance between the 250 Newton force is 1 meter. I don't know what this perpendicular distance is, and I don't know what this perpendicular distance is. However, because of the geometry of the problem, I do know if this is a distance d, this will also be a distance d. This is 40, both of these angles are 40 degrees. And if I draw a line straight down and separate this into right triangles, I know that this is going to bisect this bottom line, and I'm going to get 0.5 meters. And now I can actually solve for what this distance d is. I can say from Sakatoa, I'm looking for the hypotenuse. I have my adjacent, so I need to use the cosine of 40. So I'll have the cosine of 40 is going to be equal to 0.5 over d. I can solve for what d is. D is going to be 0.5 divided by the cosine of 40. And that number is going to be 0.653. So that's a meter. So this distance right here is 0.653. This is equal to 0.653. Now this problem becomes very easy. What I have to do is I have to sum all the moments in my problem. And I know that if I'm summing moments of a couple, well, I'm going to choose a point to sum each of the couple about, so that the point I'm summing a couple about for the moment is on the line of one of these forces. So let's look at the 600 Newton force first. Let's look at what the sum of the moments, the sum of my moments are. I'm going to go clockwise. So this is going to be equal to, we'll do this 250 Newton force first. So it's going to be 250, my force, times the perpendicular distance, which is 1. And this is going to go head first, so it's positive. Now let's do this 600 Newton force. This 600 Newton force, this distance, perpendicular distance, is 0.653. It's going to be rotating. If I go clockwise, it's going to be rotating tail first, so it's going to be a minus 600 times 0.653. And then finally, I have this force, which is unknown. If I rotate it clockwise, it's going to be positive, so I'm going to have plus my force times the distance, which is 0.653. All right. Now, what I can do is I can solve for this unknown force. I know that I want this side of the equation to equal 400 Newton meters. So if I say, okay, 400 Newton meters is equal to this 250 times 1 minus 600 times 0.653 plus 0.653f. I can solve for f. And if I solve for f, so I'll have 400, I'll have minus 250. Then I will add 600 times 0.653. I will divide this by 0.653, and I get a force, F, is equal to 829.7 newtons. And this is my answer. My force needs to be applied 829.7 newtons this way, negative 829.7 newtons this way. in order to have a resultant moment that is 400 Newton meters.